Number 90, we're asked to graph f of x is equal to 2 times x minus 5, x plus 1. This is called factored form. Factors are just things multiplied together. Okay. What's nice about this factored form, and one of the key concepts that this activity seems to be driving on, is what's called the zero product property. Zero product. And the zero product property says if you have two things multiplied together, if a times b is equal to 0, then one of them has to be 0. Then a equals 0 or b equals 0. And in this case, we mean it can be both of them. Two things, if you multiply two things together and they equal to 0, one of them has to be 0. So we exploit that here. When I have this f of x is equal to 2 parentheses x minus 5 x plus 1. What I'm going to, this f of x is just our function notation. It's another way to say y. I'm going to let this be 0. If I set this equal to 0, I can now find some x values that will match with it. I'm just finding a couple points to use, really. So I have these three things multiplied. This times this times this must be equal to 0. So one of these guys must be equal to 0. Well, saying 2 equal to 0, that's nonsense. I'm going to set both of these other ones equal to 0. So x minus 5 equals 0, or x plus 1 equals 0. Here, solving for x, we get that x is 5. Here, solving for x, subtracting 1 on both sides, we get x is negative 1. These two values are called the zeros. 0, 0. Graphically, they are x-intercepts. All right. What we have found, we have said, x being 5 gives us a y of 0. This value here is telling us that the point 5, 0 is on our graph. This value here is telling us that the point negative 1, 0 is on the graph. So when you have this form, you can very easily look here and say, hey, if I make x 5, 5 minus 5 is 0, 0 times some stuff is 0. We've got 2 points we can graph. So now, I know a whole lot about this parabola. I know that 5, 0 is one of my points. 1, 2, 3, 4, 5. There's one of my points. I know that negative 1, 0 is one of my points. Here is negative 1, 0. Now I have this parabola. It's going to open upward because this value is positive, and it's going to go through those 2 points. Now it would just be a matter of having one other point. You could find this, specifically find this vertex like we talked about before, this x equal negative b over 2a, but I'm just sketching this graph. Again, I don't know what your teacher wants in terms of a graphing calculator, but I suggest use a graphing calculator to take a look. Okay. The bottom line to this problem is, when you have this vertex form that's these things multiplied together, you can quickly relate these factors this factor can quickly tell you what this 0 is going to be. Since this is x minus 5, the 0 would be x equal 5 because 5 minus 5 is 0. Since this thing is x plus 1, the associated 0 is x minus 1 because negative 1 plus 1 is 0. These x values map to 0. These x values give you these points. Negative 1, 0 is a point, 5, 0 is a point. All right. Number 94. It asks us to find the zeros. This one's going to be super easy. Y equals negative 3, parentheses, x plus 7, x minus 1. Just like our previous one, using the zero product property. Since we have these three things multiplied together, one of them must be 0. Either this one will be 0, this one will be 0, this one will be 0. Well, clearly we won't say that negative 3 equals 0. That there's no variable there, so we wouldn't deal with that factor. I'm going to set these individually equal to 0. Hopefully you know by now it's going to be negative 7 and positive 1. X plus 7 is equal to 0, or x minus 1 equals 0. Here, subtracting 7 on both sides, we get that x is negative 7. Here, adding 1 on both sides, we get that x is 1. If we took these values and substituted them into this equation, the corresponding y would be 0. Substituting 1, we can see easily. Substituting 1 for x. 1 minus 1 is 0, and 0 times anything would equal 0. Number 94. The zeros are x minus 7 and x equal 1. Give me a holler if you... number 98... probably a little bit too much to talk about on this video, but the bottom line is this. A linear situation is one where there's a constant increase between the x and the y. So if you had some situation like this, if the x's are increasing by some constant amount, the y's will increase by some constant added amount. Here, as x increases by 1, y is increasing by 3 each time. This is a linear situation. An exponential situation, there will be a multiplier as x increases by 1, y would increase by some multiplier. In this case, we're multiplying by 3. This is times 3. Linear is a constant added amount, and exponential is some multiplier. In a quadratic, does it say quadratic in this one? Yeah. In a quadratic, the second difference is constant. So our standard quadratic is, again, if we consider this function f of x equal x squared, just squaring everything. 1 pairs with 1, 2 pairs with 4, 3 pairs with 9, 4 pairs with 16. You can see we've just squared. Looking at the second differences, here the differences, we've increased by 3, we've increased by 5, we've increased by 7. Now looking at these differences, you can see they're a constant. An add of 2, an add of 2. A quadratic relationship, the second difference will be constant. So hopefully that leads you to look at on number 98. Does demonstrate this sort of pattern. Each time the x increases by 1, the y increases by some constant.